Okay, good evening. Today is October 23rd. Hope you're doing well. We'll go through two different uh, sheets for you. The first one, Math Studies Guide, Pre-Algebra Skills. All this one is definitions. Your child's already received this. I'm going to go through this one pretty quick, and then I'm going to open up the other one and we'll actually work a few problems. There's a lot of terms, definitions that students need to know, so if you can make sure your child just reads through these each evening, it would make a big difference. The biggest thing that they'll be doing this first week is writing expressions, but we'll get into there in just a minute. All right, what is an expression? It's a combination of numbers, operation signs, and grouping symbols, like parentheses. And examples: 14 minus r, 3d plus 19, 8 minus 14 minus 5, g divided by 20 minus 16. Now we'll be starting out fairly simply with most of ours, but it will lead into more difficult ones. Now let me just show you a couple more examples of expressions, and this will tie in with some of the other things we'll be doing. All right, I've got 2n. Now what does 2n mean? In algebra, you never see multiplication indicated with a traditional times sign. The reason for that is when we get to the definition of variables, you'll see that x is often used as a variable. And this would look a little funny to have 2 times n. So instead we use this method of indicating multiplication. Multiplication in algebra is usually indicated by the number and the variable, the letter, being side by side. And that is multiplication. You sometimes see it with a dot, but rarely, so the students need to get used to the fact that if a number and a letter are side by side, that indicates multiplication. All right? A couple of other things you never see: a division sign. If I had 2 divided into 8, you'll never see that. There's one preferred method. You often see it another way, but I'll show you both ways here. All right, 8 is being divided by 2, so that says 8 is divided by 2. This will never be used. Another way of showing 8 divided by 2 is to express it as a ratio, a fraction. 8 divided by 2. When we get to our division unit, and I've already told the students, all division is, or all a fraction is, excuse me, is a division problem. That says 8 over 2, or 8 seconds, 8 halves, but it mainly says that 8 is being divided by 2. All right, so you'll see it like this, or like that. You'll never see it like that. All right, next definition, what is a variable? When we hear the weather report, they talk about variable cloudiness. A variable in math is a symbol, and usually it's a letter that takes the place of a number in an expression or an equation. Now the reason that's used is because sometimes you don't know what that number is until you actually work your problem. For example, I don't know what y is until I actually work through my equation. We'll talk about the difference between an equation and an expression later. There's some number that will make this true. This equal sign says it's my job to find a value for y to make this a true statement. Well, how do you do that? When we get down to equations, I'll explain it. But until I know that, that is an unknown. So my variable is taking the place of that number until I find it. Well, this is why they're called variable. When we talk about variable cloudiness, it could be cloudy for a while, it could be sunny, back and forth, back and forth. Well, y doesn't have to always be, in this case, y is 20. 20 minus 4 is 16. Well, in this problem, y isn't 20. Because now y has changed, its value has varied. This time I need to find out what the value of y is. 4 times something is 20. Well, what is y? Well, y is 5, because 4 times 5 is 20. So you can see that the value has varied. That's why it's called a variable. All right, the next definition is an equation. All right, I'm going to show you the difference between an equation and an expression. In everyday life, we use the term expression just to say, well, this is an expression of my faith in you, or this. Have you heard this expression? If you work hard, good things will happen. Well, in math, it's a little bit different. An expression, once again, is a combination of numbers, operations, signs, and grouping symbols. Well, an equation is a statement, and here's the difference. This is an equation. That's an equation because it's a complete sentence. In other words, I'm saying that this side equals this side. It's a complete statement. Well, this is an expression. If you look at it, you say, well, y minus 13. Well, that's not a complete statement. That is just a combination of letters and so on, and numbers and operation signs. Well, the difference is that an equation is a complete statement that says this expression equals that one. So there's the difference. All right, next definition, writing an expression. Now we'll spend time doing that in just a moment. You're changing a word phrase to math symbols. All right, some number decreased by 63. All right, we're going to let D be the some number. This is my variable. So some number I'm going to let be represented by D. Decreased, and we'll talk about keywords in just a moment. Some number decreased by 63. Well, decreased means that something is going to be subtracted from something. So I need to decrease D by 63. So very simply, I'm going to take 63 away from D. The product of 17 and some number. All right. As I indicated earlier, you'll never see this because it's very awkward. It looks like you've got two variables. All right, but product means the answer to a multiplication problem, so it would be 17C. All right, next definition, simplifying an expression. I could have something like the one that's listed here, and that will lead into something that I'll discuss in just a moment. All right, to simplify an expression, you have to know certain rules, and these rules are called PEMDAS. All right, that represents the order in which you should do your operations when you have more than one operation. It stands for parentheses, exponents, multiplication, division, adding, or subtracting. Now these two here, you do in the order that they occur. In other words, if multiplication comes first, going from left to right, you do that first. If division comes first, you do that first. Same way here, whichever one comes first, going from left to right, you do first. Now there's a way to remember that, an acronym. Please excuse my dear Aunt Sally. Parentheses, exponents, multiplication or division as it occurs moving from left to right, adding or subtracting as it occurs from left to right. So here's the thing. I'm going to give you a very simple one, and I'll show you why you have to follow these procedures. All right, let's say if I had 28 minus 10 minus 4. And I don't like to follow rules. I'm just going to do it any way I want to. So what I'm going to do is I'm going to do that first. And I'm going to get 6. Well, 28 minus 6 is 22. Okay? Now, I didn't follow my rules. My rules say if I'm going to get the correct answer along with all my classmates, I've got to go in the order that the operations occur and in the correct order that I'm told to do these. Well, I've just got subtractions. So my rule said to go straight across, left to right, take it as it comes. Now you can see the tremendous difference that I'm going to have here. All right, if I do 28 minus 10 first, I'm going to get 18. 18 minus 4 is 14. And you can see that One reason we have PEMDAS rules is so everyone in the class can get the same answer. We can't pick and choose in this case because it just won't work out. Now there are some situations where you have some leeway, but the best thing to do is to follow your rules and you can't go wrong. Now let me give another one real quick. Let's see if you've got 20 minus 4 divided by 2. My rules say to do parentheses, but I don't have any. I don't have any exponents. But I do have multiplication or division, and then I have addition or subtraction. So I've got to do this first. 4 divided by 2 is 2. Now I tell the students I need to work directly below what they're clearing out or making simpler. When I want to make it simpler, I want to see that all of this, what did it change to? Well, it changed to a 2. So now it's gone. This is what I have left. This comes down. I've got 20 minus 2. This is going to be cleared out, and I've got 18. There's my answer. Now, let me show you what will happen if you don't do that. Let's say I want to do any old way I want to. I don't want to do those rules. They're too much trouble for me. I like to do the way I want to do it. All right, so here's my original problem. 20 minus 4 divided by 2. I'm going to do this first. I'm going to get 16. Now I'm going to do this. Well, I missed it because I decided I didn't want to follow my PEMDAS rules. So it's very important that these classes follow these rules because they will be using these all the way through high school. No question about it. All right, excuse me. Now the next section, and once again we'll be doing some more problems on these in just a moment, evaluating an expression. Evaluate each when P equals 18, M equals 20. Now, all evaluating means is to find out what it's worth when you substitute those values in your expression. All right, so I'll put this one up here, and we'll be doing more in just a moment. Okay, there's the first one. M has been given to me. They say that M is 20. So what I'm going to do, wherever I see M in my expression, I'm going to replace it with 20. Now this leads into my PEMDAS rules, my order of operations. I've got 20 minus 2 plus 7. Well, my first letter in PEMDAS says I better do my parentheses first. So the first thing I want to do is do this operation. That's 9. Then I go back, starting from left to right, and I start all over. What have I not done? Well, 20 came straight down. This is now 9. Now I do 29 minus 9, and you'll see the answer on the study guide is 11. Next one, 32 plus P minus 14. Once again, it's given to me that P is 18. So wherever I see P, I'm going to replace that with 18. Now, I'm going to do it the correct way, and then I'm going to show you what will happen if you don't do it the correct way. Whenever I have only subtractions or additions, addition is fine. You can do addition any way you want to. Subtraction is not, I can't move around with subtraction. In other words, you'll see that in just a moment. I need to do this minus this first because my rules say to do it as it occurs going from left to right. All right, so this minus this is 14. So all of this has been replaced. I hate to mark through it because I might have to use it again. All this has been replaced by 14. Now, then I do the remainder of my evaluating and I get 0. Well, if I don't follow those rules, this is what's going to happen. I'm going to do this first, and I get 4. All of this has been replaced with 4 now. 32 minus 4 is 28. So you can see that if you don't go in the correct order, you're going to be in a big mess. So you have to follow those rules. And the rules are not, I tell the students, the rules are not your enemy. They're your best friend because they guide you and tell you what to do where there's no guesswork. All right, I gave you some tips here. And I'm not going to go through all these and read it verbatim, but I want to go through it. The most important thing that a student can do when writing an expression is to know what operation is taking place. And that's always given to the students, but sometimes it's not as clear as in other cases. I urge you to have your child study these words, and you may even want to brainstorm with them and talk about some other words that mean the same thing. In other words, what words would indicate to you that addition is taking place? What word indicates that subtraction or multiplication or division is taking place? So I'll go through a few of these, and I'll show you a couple of the trickier ones. All right. If I had this, I know that says there's some number y being added to 2. Pretty simple. But it gets more complex as we go. Increased by, more than, the sum of. Those also mean to add. Subtraction is one of the more difficult concepts for the students as far as these words. Decreased by, less, less than, reduced by. All right, so you can see those words are a little bit more involved. Now, division, the quotient of, you have to know quotients. One of the first tests I gave the students was know sum, difference, quotient, product. You have to know what's taking place before you can write your expression. Divided by, divided into, and we'll see that there is a difference between those. All right, multiplication is a little simpler. Times, the product of, etc. Now, I want to show you real quick some of the pitfalls, especially with subtraction. I'm going to put 3 very similar expressions. I've got 12 less some number, 12 less than some number, and we'll do more examples in just a moment. I'm trying to rush through this because these things, I know they're hard to watch in one sitting. 12 is less than some number. Now, I want to point out the last one first. I'm going to change colors here. If you'll notice, there is a difference between the first 2 and the last one. If I said these, and I'm being grammatically correct, 12 is less than some number. That's a complete sentence. That is a complete sentence. So, these top 2 are not. At the beginning of what I was working on as far as expressions and equations, I said that an equation is a complete sentence. Well, this is not an equation, it's an inequality. It means that something is not less, but it's still a complete sentence. So this is going to have a sign here between 12 and my word phrase. All right, so I'm going to do that. Now, in math, we know that this is the symbol for less than. So this last one says this, that 12 is less, and I'm going to use n for some number, than some number. All right, so the students will not be doing that the first of the week. We're doing expressions. We're not doing equations, and we're not doing inequalities. So they will not see this. They're going to see expressions which do not have this verb in it. Okay? All right, so let me get rid of this last one so it won't clutter up my page. And we're going to do the first 2. I'm going to show you why the students have to pay attention and have to be on top of things, or they're going to miss these. Even though it looks like it's so simple, it's really not. All right, the first one, 12 less some number. I'm going to let n be my number. There's my number. That's my variable until I find out what it's worth. Well, what I tell the students to do is this. Wherever I see some number, my number got cut off here. Let me put that bit back so you can see it. 12 less than some number. All right, now, 12 less some number. All right, I'm going to put a number up here. I'm going to put 5. Wherever I see some number, I'm going to put another number there, so I can think about it more concretely, and it's not such an abstract thought. 12 less some number. Well, how would I write that? Well, 12 less some number. I tell the students to put that number in there and ask them, what would it be what is 12 less some number? Well, 12 less $5 I spent is $7. So 12 less some number would be 12 minus 5. That makes sense. Now, you say, well, why can't it be this? Doesn't that say 12 less some number? Well, let's put 5 here. If I put 5 here, is 12 less some number the same thing as 5 minus 12? No, because that's going to be negative 7. Totally different. So you've got to be very cautious, very careful when you do these. All right, we'll do a few more of those in just a moment, as I said earlier. All right, let me put the next one up here. It says 12 less than some number. Well, it's going to be either one of these two ways. I know less than and less mean to subtract. It's either going to be 12 minus n or n minus 12. That's the big question. Which one's it going to be? Well, I'm going to put another number up here. I'm going to use 13. Instead of some number, I'm going to just think about 13. 12 less than some number. Well, I'm going to put 13 wherever I see n up here. And let's see which one is right. 12 less than 13. Which one of these says 12 less than 13? Well, what is 12 less than 13? Well, 12 less than 13 is 1. So, this one says 12 less than 13. Because if I substitute that value, I get an answer that's reasonable. This one does not say 12 less than 13. That one says 13 less than 12. Okay? All right. Once again, we'll do a few more of those in just a moment. All right, next section. I've talked about order of operations, making sure you do everything in correct order. I won't be doing any of these here. I just want to point out that this section does go through in detail what order should be done first. Do what's in parentheses first, just for example, then subtract this number. Do what's in parentheses first, then subtract. Do the multiplication first, then divide this number, then subtract. Multiply, divide, subtract. All right, so if you follow those rules, parentheses, exponents, they won't have any exponents on this paper at all. Multiplication or division as it occurs, going from left to right, adding or subtracting as it occurs, going from left to right. All right, if you did follow those rules, you cannot mess up. Please excuse my dear Aunt Sally, is the best way to remember. All right, now, evaluating, all you're doing is substituting. Down here at the bottom, I'm not going to go through these in depth either, or either. I just want to point something out, how I did this. I did this in the correct order. Let's look at the first one. The first problem is A minus B minus C. Well, I've got parentheses. So if you notice out beside on all of these, I actually show you the steps that I should have done first. I need to do this first. So there's my 8. Then I go back and say 22 minus 8. All right, so when I start out, I've substituted, I do what I'm supposed to first, and I arrive at my answer. So that explains what all that is there. All right, but we'll be doing a couple more of those in a moment. All right, now I'm going to switch over to the other working copy that we're going to do. And I'm not going to do, that's not the right one. I've got about 3 or 4 loaded here. There we go. All right, now I'm only going to pick a few selections from these. Hopefully this will clear up. The first thing we're going to be doing this week is writing each phrase as an algebraic expression. Use the variable n for all expressions. Now this is almost like a sample test. The students will be doing this as we go through the week. All right, so let's go ahead and do a few of these, and I'll try to do some of the ones that are more difficult than others. 10 less than some number. Well, I'm going to use n, and once again I see the keywords less than. Well, what should I do? Well, I know I'm going to subtract. The big question is, which number letter comes first? We use a property. Let me just say this real quick. This is the commutative property of addition. It says that it doesn't matter one bit what order I add numbers in, two numbers in, I'm going to get the same answer. That's the commutative property of addition. Here's the commutative property of multiplication. It says, once again, I can multiply these numbers any way I want to. It doesn't matter. I'm going to get the same answer. 5 equals 5. 6 equals 6. Well, it doesn't work that way with subtraction and division. That's why these two operations are more difficult. I can't say that 3 minus 2 equals 2 minus 3 because it doesn't. This is 1, this is negative 1. So they don't equal. I can't say that 12 divided by 4 is the same as 4 divided by 12 because it's not. This is 3. Well, 4 divided by 12 would look like this. 4 twelfths. Remember I said that division and fractions have a very close relationship. This is a division problem. So students are learning to simplify some of them right now. This is 1/3. And we know that 3 doesn't equal 1/3. So you can't put them in the order you may want to. You got to put them in the order that you have to. All right, so we'll have to be careful on some of these. Now, 10 less than some number. I know I'm going to subtract. How does it go? Will it be 10 minus n or n minus 10? Well, I'm going to do the same thing that helped me earlier. I'm going to just pick a number. It doesn't matter if it's smaller, larger than 10. Has no bearing on the outcome because all this does is allow the students to use some kind of concrete method to think about their answer. Well, I'll use 20. It doesn't matter one bit. All right, I'm going to put a 20 here, 20 there. 10 less than some number. Well, what is 10 less than 20? Which one of these will tell me that? 10 minus 20 or 20 minus 10? Well, what is 10 less than some number? When the number is 20. Well, 10 less than 20 is 10. Well, which one of these will give me 10? Well, this certainly won't. That'll give me a negative number. But this one will. So I look back and say, wait a minute. If 10 less than some number should be written like this, well, I need to write this. All right, so you can see if the students will plug a number into their expression, it will help them. So I've got 10 less than some number, and that will work out. All right, now I'm going to do a couple more of the tricky ones, and we'll move on. That one right below there, let's go ahead and do number 3. 5 decreased by some number. Decreased indicates subtraction. So I'm going to do either 5 minus n or n minus 5. Well, which one is it? It can't be both. Well, I'm going to put, let's say, I'll just put 20 again. 5 decreased by 20. I'm going to write it like this. I'm going to write it like this. One thing in 5th grade that confuses students, they've been told since 1st and 2nd grade that you can't take big numbers away from little ones. Well, now they're finding out that you can, because you can get a negative value. Students are going to learn their rules for integers. In other words, adding, subtracting, positive and negative numbers, multiplying, dividing, and so on. Now they know that I can have $5, but I can owe my mom 20, and I'm in debt. They understand that now. Before they were told, no, you cannot take a big number from a little number. But now they know in real life we can. 20 minus 5 is 15. But you can see those are totally different numbers. All right, so which one is right? 5 is being decreased by some number. I've got $5. Well, that's going to be decreased by $20 at some point when I get enough money to pay my mom back. So when I give her my 5, I still owe her 15. So which one of these statements is correct? Not a statement, excuse me, expression. 5 decreased by some number is correct. Be very cautious on subtraction and division. Adding and multiplication not near as difficult. You've got more leeway on those operations, and I'll show you number 2. 7 more than some number. 7 more than some number. Whatever that number is, if my number, let's say if n is 12. What's 7 more than 12? Well, it's 19. So this works out. Now, this is okay. Either one of those is fine. But they're going to find out later that if it says certain situations, they have to put one in front of the other. And I'll show you that in just a moment as well. Trying to make sure I include all the little pitfalls they're going to find. All right, the product of some number and 14. Product is multiplication, the answer to a multiplication problem. As I told you at the start, you never see a times sign. You're going to see the number and the variable side by side. The product of some number and 14 would be 14n. Now you're not going to see this. You say, well, what's the difference? Why can't you put the variable first? Well, you wouldn't say that I have 14 dozen, excuse me, you wouldn't say you had dozen 14 donuts. I don't have dozen 14 donuts. I've got 14 dozen. So the number comes first, the variable comes second. I don't have shoes 2. I have 2 shoes. Alright, so the number comes first, then the variable. Alright, so that's important. The number first, the variable second. I don't have n 12s. I've got 12 n's, and that makes sense. Alright, let me do a couple more of these. Alright, reduce 6 by some number. I can't do them all or we'll never get done. Reduce 6 by some number. I've got 2 choices. Reduce means to subtract. It could be n minus 6 or 6 minus n. Well, let's put a number in there. It doesn't matter if it's big or small. Let's do 20 again. I like 20. Alright, which one of these says to reduce 6 by 20? Alright, I've got $6. I'm going to reduce it by 20. What do I have left? Well, I don't have anything left, and I'm already in negative territory. So which one of these says reduce 6 by 20? This one does. Put a number in there, replace it where your variable is, and it helps you a lot. All right, so the correct answer is reduce 6 by some number. It should be reduce 6 by some number, and you got it. All right. Now, more than, that's pretty simple. This one's tricky right here. 81 less some number. I highly recommend you tell your child to write down, when it's a subtraction or division, write down both ways. It's a little bit more work, but I promise you it will pay dividends. 81 less some number. I'm going to pick a number again. I'm going to do 20. There's my 20 again. 81 less 20. Well, what is 81 less 20? I've got $81 less the 20 that I gave someone. I've got $61. Which one of these will give me 61? This one will. Right there. So 81 less some number would be 81 less some number. Now, let me show you number 8 real quick. And this will lead into something that the students will see the rest of their school career as well. The quotient of some number in 12. It just says to find the answer to a division problem. The quotient is the answer to a division problem. Well, this is what you need to do here. The quotient of some number in 12, whichever one is listed first, comes first in your expression. So here it says the quotient of some number and 12. You'd write it like that, or preferably like that. That shows the quotient of some number 12. You say, why does it matter? Well, here's the issue. Which one is correct? This is the quotient of some number in 12. Could it be here? Well, technically not, because that is the quotient of 12 and some number. All right, so whichever one comes first in these cases, you put them first. Now, same way with the word difference. if I've got this statement, the difference of 20 and some number. Well, technically 20 should be first. The difference of 20 and some number. So if it just says the difference of the quotient, go ahead and write which one comes first in your expression. All right, let's move on. Or once again, it will never get done. Here, you're writing each expression in words. Example, D plus 12, a number plus 12. Now, these are pretty simple. The students do well on these. I'm going to just pick a couple of these. There are umpteen options to write t minus 5. You can write t minus 5, but I'll show you a couple of others too. You could say t reduced by 5. That says the same thing. You could say t decreased by 5. Pardon my writing. I try to hurry and it makes it mad. Sometimes decreased by 5. You could say t less 5. Or you could even say 5 less than t. So the students have many options on this, and you can see that basically as long as they can go back and say, well, this does fit, there's no way they can miss those. All right, I want to point out a couple of these that have more than one operation. If you look at 20 and 21, 18 minus f divided by 3. Basically all this is saying is that you're going to subtract f from 18 first. So you could write this as simply 18 minus f divided by 3. And as in the previous examples, you've got all kind of ways you could say it. So these, I don't want these to be hard. Those are basically understanding what you're asked to do and in which order. All right, now evaluating quickly. Evaluating expression, all you're doing is substituting a value that's been given to you. All right, I'll do a couple of these. We'll just start with the first one. It says, I've got parentheses, so I've got to do that first. I'm going to put, wherever I see R, I'm going to put 5. So the first thing I'm going to do is I'm going to write my expression out. Students like to cut corners here. They don't like to write stuff for some reason, but writing it out is the key to getting it right. I need to do this first. So right below here, I'm going to put my answer. Well, that's 4. Right below here, I'm going to put what I haven't done. Right below here, I'm going to do this, and I'm done. Now, that didn't take me but a couple of seconds. A little bit more than a couple of seconds, but a very short amount of time. If they'll write it, I tell them it's going to look like an inverted Christmas tree. And you that have taken high school math, you remember having to simplify and so on, and you have to show every step. This is getting the students ready for higher math, where they've got to show and justify everything that they do. All right, and it doesn't take that long. All right, let's do this one here. I'm going to write it down first on my paper. I'm not going to rely on a little bitty piece of paper that's got another problem right below it, because I can't see what I'm doing. Everywhere I see G, I'm going to substitute 3 for it. All right, so 9 times 3 plus 7. As I indicated earlier, I'm going to decide what I want to do first with my rules. My rules tell me I better do my parentheses first. Well, this is going to be replaced with a 10. Now, I'm going to go back, I'm going to write what I haven't done. Well, I haven't done this, so I'm going to write it down again. Students, they get in such a hurry to get done, and I don't know what the hurry is. They've got to stay here 6.5 hours a day, so there's no hurry. They get in a hurry, and they don't want to write these things down. And this is going to guide them and help them get everything right. I've done this now. It's gone. Here it is. I haven't done this. I bring it down. Well, there's my answer. Now, if I don't go in that order, I'll miss it. Let me do one more of those. All right, let's see. Let's do this one here, just to make sure we all understand what that means. That says m over 8. Well, it actually just says m divided by 8. So remember, when you see that fraction bar, that indicates division's taking place. So I'm going to do this. I've got 32 over 8. Now I can simplify that as a fraction, and some of the students are still hazy on this because we technically haven't covered it with some classes. But all this means to do is to divide the denominator, the bottom number, into the numerator, the top. So 8 into 32 goes 4 times. So there's my answer. Next section is simplifying an expression. Basically all you're doing here is taking what's given here. Here you had to replace a variable with a value, just like here. If you can see, R was 5, S 16, so on. Wherever you saw those, you replaced them and you moved on using your PEMDAS rules. Well, the bottom section, you're just given an expression and you're simplifying it using your rules. Alright, parentheses, exponents, multiplication or division, whichever comes first, moving from left to right. Addition or subtraction, whichever comes first, moving from left to right. I'll give an example. I have to do this first. If I don't, I'll miss it. All right, let's just do a couple of these and we're almost finished. All right, 32. 35 minus 25 minus 10. All right, I'm going to do it incorrectly. I know doing things incorrectly is probably not a good teaching tool, but I do want to graphically illustrate to you that if you don't go in the right order, you're going to miss it. Well, I'm stubborn sometimes, and I don't want to do what my rules tell me, so I'm going to do this first. I'm going to do that. Well, I'm going to get 15. Then I'm going to go back, and I'll do this now. Well, I got 20. I think I'm doing fine. I don't see any problems mathematically with what I did. Well, but none of my classmates have that summary. I don't understand why. Well, here's why. I needed to do this first. 35 minus 25 is 10. I haven't done this yet. 10 minus 10. Then all my classmates that had 0 look at me and say, well, if you'd have followed your order of operations, you'd have got it. So there's one of those rules are there. All right, let's just do a couple of these real quick. Let's do 36. It looks like a pretty good one. I'm going to write it on my paper away from my problem because I don't have sufficient room to work it. First thing I'm going to do is what's in parentheses first. Then I'm going to bring it straight down right below it. This is 18. Alright, I haven't done any of this. I'm going to write it again. Make your child write down everything they haven't done. It's payoff. Now, I look at it, I decided what do I do next. Well, I've got subtraction and I've got division left. What do I do first? Well, I've got to do my division. So if I come straight down, 18 divided by 6 is 3. 50 minus 3. I haven't done this. I start left to right again, and there's my 47. And everything worked out quickly. And I'm no smarter than any of my students, and you can see it didn't take me long to do that at all. So there's no reason for the students to say, I don't like to write all that down. It's too much trouble. Well, it's really not too much trouble. That's what's going to keep them from missing problems. All right, I want to do one more of these. Let's do 37, and we're going to wind it up. All right, I'm going to write it up here, away from my other problems, so I'll have plenty of room to work. That took me 5 or 6 seconds to write that down. All right, the first thing I'm going to do is do what's in parentheses first. 75 minus 70 is 5. Now, I'm going to bring everything down that I haven't done. That ensures that I don't leave anything out. Well, what do I do now? My rules say when I only have subtraction, just go from left to right, whichever comes first. So this is being replaced by 24. I haven't done this. 24 minus 10 is 14, and I'm done. All right, I hope this has helped some. As always, feel free to email or call me. I'm more than happy to respond. I want to remind you, students can redo math tests when they're having trouble. Best time to do that is at 7:30 in the morning because I'm always here. They can just come on in and start. And I've had several students that's doing this. I strongly encourage you to allow your child to do this if possible. All I'm interested in is that they understand what we're doing. I don't worry quite as much about the grades as probably the parents and children do. My main goal is that they understand it, so when we go into the next unit, that it makes sense to them as we move from unit to unit to unit. Contact me, email, call me, whatever I can do to help, and give me some feedback if these have benefited you, or if you can see any way that I can make improvements. All right, thank you very much. Have a good evening.